So let's briefly recall the four fundamental forces that we know in nature. So first we have the electromagnetic force, which is mediated by photons. And next we have the strong nuclear force, which is mediated by gluons. We have the weak nuclear force, which we have W plus minus and Z naught particles. We will be learning about them in the later lessons. And then last we have gravitational force, which is thought to be mediated by the graviton. So among these four particles, photons, gluons, W plus minus and Z naught, and graviton, only the graviton is not yet experimentally discovered in our time. So one of the reasons why is it very hard to detect is that gravity is very weak compared to the three other forces. So to see how gravity is weak, to see how much gravity is weaker compared to the three forces, we have here their relative strengths. So we assign the strongest one to be we know that the strongest one among the four is the strong nuclear force. Next is the electromagnetic force, which is only 100 times weaker compared to the strong nuclear force. And then we have the weak nuclear force, and then among them, gravity is the weakest. So these four fundamental forces only act at specific ranges. So for the electromagnetic force, we know that it is governed by the inverse square law, 1 over r squared, and it can act on very very long distances. The strong nuclear force only acts inside the nucleus. Hence, it has a very very short range for about 1 femtometer, 10 to the minus 15th of a meter. Then the weak nuclear force is much smaller in range. It's about 0.001 of a femtometer. And then, of course, we have gravity, which is similar to the electromagnetic force. It can act at very long distances.